Hey guys, Mr. Weens here. We got another science lab to go over. We're still talking about the physical properties of matter. Another physical property of matter is magnetism. Magnetism is the property of attraction to a magnet. So we are going to see which items are attracted to magnets and which are not. Stay tuned. Right. Now, around every magnet, there's an area called a magnetic field. Because of its magnetic field, a magnet does not have to touch a metal object in order to attract it. If a magnetic field is strong, the magnet can attract the metal through non-magnetic materials such as water or plastic. We're going to test that right now. I have a plastic container full of water. I have some steel beads here. Pour those into the water. All right, class. Now here's the question. Do you think a magnet will be able to attract these metal balls through the water? Let me grab a magnet and we will test this out. All right, here is our magnet. This is a bar magnet. The red side's north, the blue side's south. Every magnet has two poles, north and south. We're going to place this in the water and see if it attracts. Look at that. See if you can tell. But it did attract them through the water. Right. Okay, we have demonstrated that a magnet can attract objects through water. Now we're going to see if they can attract objects through other materials. So here's our steel balls. We'll put those in a tray. They're still wet, but it'll still work. All right, first we are going to try a piece of cloth. This is a microfiber cloth used to clean electronic devices. I'm going to place this over the top, get our trusty magnet, and we're going to see if the magnet can attract the balls through the cloth. Here we go. Well, let's see. It sure did. Look at that. Stuck to the cloth because of the magnet. Okay. Okay, so cloth worked. I'm trying to catch all these metal balls as they fly away. Okay, cloth worked. We got a piece of tissue paper here. It's thin. I'm going to double it up to make it a little bit thicker. This is a tissue paper or paper towel that you would find in the bathroom here at school. We're going to put it on top of the balls. All right, make your prediction. Will the magnet be able to attract these balls through the tissue? We're going to find out in 3, 2, 1. Oh, you can't see it, but I could hear it and I could feel it already. It did. The tissue was no match. Okay, let me take this off. Try to keep all the balls in the tray. Excellent. Okay, so far it went through the tissue. It went through the paper towel. All right, I got a piece of paper here. Standard printing paper, what you would print on through a computer. We're gonna put it on the tray. It's thin. Do you think it will be attracted? We're gonna test it out. Make your prediction now. 3, 2, 1. I think you could hear that already, and sure enough, it is attracted. The paper did not stop it. Okay. Pause, get all these marbles back in here. Oop, I made a mess here, guys. Give me a second. Okay, guys, we are back. Sorry about that. Had a little mishap. So just to recap, it went through the tissue. It went through this paper towel. It went through the paper. Now I have a piece of cardboard. A little thicker than the other things we've tested so far. Make your prediction. Will the magnet be able to attract these steel balls through the cardboard? All right, got the cardboard on the tray. Got the magnet in my hand. Make your prediction. Here we go. 3, 2, 1. Oop, I could hear it. I got a strong magnet, guys. It even went through the cardboard. Look at that. It is attracting them through the cardboard. All right, good job. And we will be right back. All right, guys. So far we have been using permanent magnets. Now this is an example of a permanent magnet. This is a magnet all the time. There's no turning it on or off. Here's another example of some permanent magnets. But now what I'm going to show you is an electromagnet. Now, electromagnet is a metal rod with a wire wrapped around it. When the electricity goes through the wire, the rod becomes a magnet. How does this happen? Well, an electric current is a flow of small particles called electrons, which create magnetism when they move in the same direction. When an electromagnet's wire has electricity running through it, the rod's electrons will move in the same direction, making a magnetic field. This rod is a temporary magnet. When the electricity is turned off, the rod is no longer magnetic. So for example, this is an electromagnet right here. Without electricity, it will not attract anything. See that? The balls are not attracted to it. Nothing. But I have some electricity in this box right here. I have 2 AA batteries. And I've got cables to connect electricity to the magnet. So first we're going to hook up the negative side. And we'll place one side to the battery, one side to the magnet. Same thing with the positive side. One side to the battery, one side to the magnet. And now remember how it wouldn't attract the balls before? Now watch. It is attracted. We have electricity going through these cables. Now what do you think would happen if I stopped the electricity? If I unplugged this and made the circuit incomplete, what would happen? Are the balls going to stay where they are, or will they drop? Make your prediction. I'm going to unhook it in 3, 2, 1. Oh, wow. No electricity, no magnetism. Let's try that again. Now there's electricity. And now they're stuck. I took the electricity off, and they're gone. Can you believe that? All right. Cranes and junkyards have giant electromagnets. They lift cars with them, heavy refrigerators, and then they turn off that magnet and it drops whatever they have. All right. Moving on. All right, we are back, guys. We are just gonna test different objects now and see which one the magnet is attracted to, or which items are attracted to the magnet. Some of these might seem a little silly, but we're gonna test them anyway. First, we have a rubber band. Rubber band. Do you think it will be attracted to the magnet? Nothing. Not a thing. Not attracted. This is not magnetic. Next, we got a toothpick made out of wood. Make your prediction. Will it be attracted or not? Nothing. No magnetic attraction. Okay, we have this little tack or it goes in your braided folders. It's made out of a metal. Is it the kind of metal that's attracted by magnets? Let's find out. Yep, sure is. This is magnetic. Hey, I got the remote to my Apple TV. It's got a metal case. Do you think it's magnetic? Let's test it out. Ooh. So magnets are only attracted to certain types of metal. Those metals are iron, steel, nickel, and cobalt. This is made out of stainless steel, so it is not attracted. Okay, I have this button. It says Public School Proud. It's made out of metal. I don't know what kind of metal, but we can tell if it's iron, steel, nickel, or cobalt by whether or not it sticks to this magnet. Let's check it out. Wow, it's stuck really well. So it is either iron, steel, nickel, or cobalt. Next, I found this metal race car. It's almost like a Hot Wheels. It's got some plastic to it, but the top part is metal. The bottom part's plastic. Do you think the magnet will stick to it? Make your prediction. And it does not at all. It is not attracted to magnets. All right, I found these old school pair of scissors. They're made out of probably steel. Looks like it could be stainless steel though. See how shiny that is? All right, we're gonna test it. Make your prediction. What do you know? It sticks. All right, so that is made out of steel. Now, I don't know how well this is gonna show up in the camera. We're gonna do our best. In here, I have iron fillings. These are shavings off of a bigger piece of iron. They almost look like grains of sand. See how they move there? Now I told you that they're iron fillings. So iron is attracted to magnets. Let's see what happens when we put a magnet to this. Ooh, that's pretty cool. I don't know if it's going to show up in the camera or not. Let's do it from this other side. It's making a bunch of weird shapes and spikes. Can you see that at all? Tough. All right, finally, we're going to do one more thing here. We're going to see which of my magnets are stronger. We got a bar magnet, or a brick magnet. We got a ring magnet. And then we're going to test out our electromagnet as well. Now, in order to do this, we're going to put this. We know this is attracted. And we have a trusty little ruler on this piece of paper here. So, we're going to put our metal brad right there. We're going to see how close we have to get to it before it is attracted to the magnet. All right, now I'm 10 centimeters away, 9 centimeters, 8, 7, 6, 5, 4, 3 centimeters away, 2 centimeters away. Oh, look how close we had to get. That's not very strong, is it? All right, let me mark that. We were right at half a centimeter. Half a centimeter. Okay, we'll put our brad right back here again. Next, we're going to try our brick magnet. Got it back here at 10 centimeters. 9, 8, 7, 6, 5, 4, 3, 2. Oh, I see it moving. Oh, 2 centimeters. It only had to get within 2 centimeters for it to work. Let's try that again. We're at 4 centimeters. 3 centimeters. 2 centimeters. So right now, this brick magnet is the strongest. All right, now we are going to test our electromagnet. I just got to get it hooked up again. Give me 1 second. All right. Hook up my cables, red to positive. Blue to negative. Okay. Hook up my magnet here. This is a temporary magnet. It only works when it has electricity going through it. Okay, now it is a magnet. All right, it's gonna be a little trickier. All right, we're gonna start at 7, 6, 5. We're at 3, 2. Ooh, that's not very strong at all. We had to get right on it. Let's try it one more time. Make sure my cables are hooked up. All right, now, it wasn't very strong. Electromagnets are only as strong as the electricity going through it. Right now, I only have 2 AA batteries in here. If we were able to increase that to put maybe like 2 car batteries, this would be stronger. So right now, the strongest is our brick magnet. Next, we're going to try building stuff with these metal beads. Now right now, you can't really stack them on top of each other. You put them on top of each other, they just fall right off. But let's see what happens when we add some electromagnet to it. Now, it makes it a little more pliable. Now you can get them to stick together. Look at that. We're building a tower now. See that? Now, the more brick magnets you add, the more magnetism there is. So we're going to add all of these. Oh yeah, now we should be able to make this really tall. Look at that. We can go real tall with it now because we have all the magnets working together. Now what happens when I release it from the magnet? They all fall back down. Put them on the magnet, and you can, makes it almost feel like Play-Doh, the way they stick together. All right, one final demonstration I want to show you guys using our ring magnets here. Now, magnets all have a north and south pole. Opposites attract. You cannot get 2 north sides of a magnet to stick together. All right, here's the north side of this blue magnet. Here's the north side of this yellow magnet. They will not, they repel each other. You can feel them pushing against each other. I can show you by placing them on this thing here. We're going to place them the opposite way. See how they won't go next to each other? Whoops, those are opposite tracks. Let me flip it over. Look at that, they will not touch each other. You can move them all by touching this top one. See that? It's like they're defying gravity. It's floating right here. They're floating because of that magnetic field. Now, right now we got north on north, south on south, so they are not going to attract. We take them off here, let them do their things. Boom. Now they don't float anymore. All right, guys, that's what we got for magnets. If you have a magnet at home, be careful with them. Keep them away from electronic devices. Keep them away from your TV, your cell phones, your iPads. Magnets can mess up all of those things. But have some fun and see what you can attract with them.